Professor Emad Madha.
And I'm
Professor Philip Wang.
And today we are conducting an experiment on gel electrophoresis.
Okay, so now we are preparing the gel. And what we have done
It's really funny because my mom did that to
is we have taken a solution
I'll be right over in a second with the microwave.
deionized water with TAE.
We got the comb at the black.
Okay, that's a buffer that we're using for the gel electrophoresis machine to help conduct electricity throughout the gel. This is the solution that's going to become the gel. What it is we took 400 milliliters and made a one-time solution of TAE with 398 milliliters of deionized water, 392, sorry, and 8 milliliters of TAE, of 50 times TAE, to come up with a one-time solution of 400 milliliters. Now we took 30 milliliters of that, so now this is 300 micropipette. We took 30 milliliters and put it in a solution, made a solution with 0.3 grams of agarose, which is a seaweed extract. So this solution in this erlenmeyer flask right here is eventually going to become the gel for our gel electrophoresis. That is the machine that runs in the back right here that I'm pointing at. This runs electricity through it. Professor Emad here again with Professor Wang and our solution. We're going to go microwave the solution. Now the goalie Philip, who actually plays defense, is taking the solution out of the microwave. We microwaved it until it started boiling over. Or not really boiling over, but it was heavily boiling. It's smoking because it was really hot. Now let's go take it over to the table. Okay, so now we're going to let it sit for 3 or 4 minutes to let it cool off.
Here's our basic setup, right? This is the casting gel tray. Here are our spacers here, alright? The next thing we want to do is put the comb in. The comb always goes closest to the negative electrode. That way everything's going to run from negative to positive. So that gives us your arms. So Philip, see what we did here? So we have the spacers, we have the basic casting tray here. Let me take this out. This is our basic casting tray, right? That's what's going to mold our gel, right? Here are the spacers to avoid leakage. And then the comb is always going to go closest to the negative electrode. So everything's going to run in this direction. So about 2 more minutes, you can pour the entire compound.
Okay, that's what we're going to do.
Hello, this is Professor Wang and Professor
Emad.
And today we'll be extracting the water.
This is a micropipette, and right now we have it set to, I don't know how well you can see that, but the number is 32. We're extracting 32 milliliters of deionized water. Okay, so making sure that we use the proper pipetting technique, we will extract down. So always use your thumb slowly. Always. Okay, and push it down to release before you put it in your solution. And then slowly retract. And here we have
32
milliliters of water.
Microliters.
Microliters.
There you go. To the bottom and now dispense.
Not milliliters, microliters. This is the empty container that we are now putting in the deionized water. Right, now I'm putting, this is our deionized water that we had, 32 microliters, 8 microliters of loading dye. Now we are waiting for the gel that we put in the electrophoresis machine to solidify. We put it in between those 2 black spacers, okay, where the comb is, and the comb always goes to the farthest notch, so it's as close to the negative electrode, which is the black circle with the gold knob sticking out of it. That comb with that's the white thing there, goes as far to the left towards as far as it can to the negative electrode. Okay? And right now the gel is in there, in that spot between those 2 black things, the spacers, so that it can solidify.
It should be this color.
It should be that color.
Well, because I didn't get to watch the video on how to work that.
Okay, here we have our gel electrophoresis machine going. Okay, you can see it's starting to steam up because the buffer is heating and evaporation and whatnot. You can see the dye is starting to move a bit. We have it plugged in. This is a gel electrophoresis machine. Farther along in the process, it's hard to see because steam's in the way, but the dye is moving. I don't know how far you can see, but if you look closely, it may be hard to see, but the dye is definitely moving along.